Hello everybody, we are a group of researchers from the Delft University of Technology in the Netherlands, and we would like to present today our demonstrator for the Day 2020 exhibition addressing FPGA cloud integration. Our demonstrator shows a real-time Snappy decompressor and filtering using our Fletcher framework. First, we start with the motivation of the work. If we look at big data analytics developers today, those developers develop their solutions using very high abstracted languages like Python and Java on a big data frameworks like Spark and Dask to develop solutions within a couple of days that run on highly scalable cluster infrastructures. On the other extreme, we have hardware developers that develop ultra-low level implementations on hardware platforms like FPGAs. Those solutions are usually highly optimized, and they are developing using logic gates and bits and bytes. Developments of this type takes a couple of months to be able to be completed. In order to be able to bridge this gap between the expectations of big data developers to develop solutions within a couple of days and the long time needed to develop highly optimized hardware solutions, we use our Fletcher framework to be able to support this kind of development. Our demonstrator takes in Snappy compressed dataset, is able to decompress this data real time on an Alveo U200 FPGA with a throughput of up to 30 gigabytes per second. Such kind of throughput allows us to decompress the whole Wikipedia English datasets within a second and achieves a performance that is 4 times higher than what you get on high-end servers. Developing this kind of solution took us about a couple of days of integration time.
So on to the demo. This shows up on the demo page. It has a nice figure of how the runtime component looks like. So again, on the left is the Scala data preparation application. So Apache Arrow, we put the generated IPC files into the memory. Then when they are in the memory, the host application or CPU application can do the computation. And also we make a copy to the device so that the arrow tables are in the device memory. Then from the web application, you can do queries. And these queries are then executed on either the FPGA, and the results are sent back, or they are executed on the CPU, in which case the results are also sent back. On the FPGA, the arrow stuff is in the device TDR, like I just said. We have the SDXL shell together with the Fletcher generated interface. On top of that, we have the Snappy decompressor and also the pattern matcher, which takes care of the matching of the words. All right. So maybe nice to mention here is that actually we had an initial solution in 2 days, and that was a very nice result that even we didn't expect. And part of our value proposition is that we try to focus on development and integration, and actually we showed that we actually did better than we expect. So what we can do is we can type a query, then it will go search. There are some options. So the kernel allows you to enable whole word matches. You can also specify a minimum number of matches, because if the number of matches is extremely large, we just return the first, I think, 100 or 1,000. So you can increase that number to get the results you want. And also for the CPU comparison, you can specify the number of CPU threads. Nice thing is here, we also have some, let's say, information from the server, the power uses of the FPGA. And actually, if we run a query on the FPGA, you can see it go up to, let's say, 50 watts or something. All right, so this morning, actually, I found a very nice query that gives an interesting result. So let me show you. All right, so if we search for this, we can all guess what shows up, but actually the result is rather interesting. So there it is. Actually, the Wikipedia page from Peter Hosse, he has one, is the top result for this query. And as you can see, the Alveo did it in less than a second. Now we can also run the same query on the CPU, and it will show you that it's much slower. It takes a little bit more time. And this is using 40 CPU threads, so in this case the speedup is about 4.7. But for some queries it's different. CPU performance is a little less predictable than the FPGA. But now we can go and try different queries and see what shows up. But if we search for banana, oh, this is on CPU, so this is going to be slow. Now if we do the same thing on the FPGA, boom, there it is. And we also list all the other results that have banana in their article text.
Thank you for listening today. We would like to thank our core developers in Delft University, our students, and our advisors. And also, we'd like to thank our external supporters from Xilinx and the FitOptivis European project. If you want more information about Fletcher, you can access our GitHub site on the link below and check more examples and more implementations down there. Thank you very much.